All right, crew. I've started this about 3 times. All right, we're going to talk about hang time. How long, right? Well, it's pretty complicated. Actually, there's a lot of stuff going on. Okay, as you can see in when you watch the movie with the little 6-minute sports science video on hang time and Jordan Farmar leaping, he talks about getting way low and changing the center of mass, and that's basically what you're doing. You're trying to throw your center of mass up in the air. Let's just take a look at this. So when I take a ball and it comes, and we're going to do coefficient restitution too. All right, this ball's on the ground. It can't go anywhere. All right, but if it bounces, it's got a force that pushes it back up. All right, and that's coefficient restitution, which we'll look at later. But when I have this ball in my hand, okay, and I want to throw it in the air. All right, so I throw it in the air like that. All right, when I throw it, I apply an impulse force to it for a short amount of time. It's like a small collision, like we were doing before with Serena's serve and stuff like that. But it's a little bit longer of an impulse. And so it's got a force times a distance. So you're doing work. And then once it leaves my hand, once it is in the air, the force that's working on that ball is the pull of gravity pulling it down. All right, now the equal and opposite force in that case is up on the earth with the same force that the earth is pulling down on it. So this little ball produces this little, it's probably like a tennis ball. So I'd say it's actually a racquetball around 0.08 kilograms. Let's just make the math easy. Let's call it Newton of force. All right, 0.1 kilograms in it's being pulled down with about 1 Newton of force, okay? And it's pulling up on the earth with 1 Newton of force, and do you think the earth cares? No. So, but I've got a force times it. The same thing happens when you jump. The same thing happens when you jump. You're lowering your center of mass. All right, so here's what you're doing. You're lowering your center of mass, and I'm not going to jump or anything like that, but you're lowering your center of mass, then you push off with your legs. And you're pushing, your legs are right underneath your center of mass, and that's what's pushing you up. All right. Well, you push down with your legs, and the floor pushes you up. That's the action reaction. Once your feet leave the ground, acceleration due to gravity takes over. That's the big idea behind this. All right. So there's the intro, and we got that done. I've tried this 4 times. We finally got that done. So let's get out of this. And we're still running here. So